The following is a special presentation of KWQC-TV6. In the next half hour, KWQC-TV6 examines the history and science of weather forecasting. Tonight, take a closer look at how technology has changed the way you receive weather information as TV6 presents Eye on the Storm, a change in the weather.
Good evening, I'm meteorologist Terry Swails. You know, there's an old saying that the more things change, the more they remain the same. But nowadays, as technology changes almost daily, that adage just doesn't hold true. Advances in technology are changing the way we work and play, eat and sleep, the way we receive information, and the way we share that with others. That kind of change is happening here at KWQC-TV6 as well. Advances in technology are redefining our understanding of weather in general, severe weather in particular, and the way that information gets to you, the viewer. That's what our program is about. I'll show you the latest advances in weather forecasting, and we'll see how that works to give you fast, reliable weather information that you need to know and you've come to expect from KWQC. Erik Maitland will take a look at what the future holds and show you what that'll mean to you as technological advances move off the drawing board and into our lives. Now, to better understand where we are and where we're headed, we need to take a look at where we've been. And here to help us with that is our own Theresa Bryant. Theresa.
Thanks, Terry. Well, this is a strange sight, a weather person at the Putnam Museum. Usually weather people don't deal in weather history, we deal in weather future. But history is a very important part of what we do today, and it can give us an interesting glimpse into the future. Here's why. The weather is more than just the temperature where we live. Weather from across the country can influence many aspects of our daily lives right here in the Quad Cities. Reconnaissance flights, computers, and TV6's use of Doppler radar allow us to actually see what's going on in the atmosphere and produce better and more accurate forecasts. But it wasn't always that way. It started with simple physical observations. The ancient Greeks studied weather as a military factor in their battles with other civilizations. Certain inventors and great thinkers throughout history have contributed much to what we know about the weather, but accurate measurements of temperature, precipitation, and atmospheric pressure didn't really begin until the 17th century. That's when instruments such as the thermometer and the barometer were invented. Next came the telegraph, making actual weather forecasts possible as well as practical. Members of the U.S. Army Signal Corps were responsible for the first government weather forecasts in 1870. 1 year later, an observation site was established here in the Quad Cities. Historians note that those first Weather Service sites were not exactly state-of-the-art.
Some of the old stations, I know they had people or observers, they'd take one observation a day, maybe two readings a day, and that was the observation. And if it was snowing, you reported the snow, and there really wasn't much of a forecast process in it. It was just more of a monitoring what's happening and log it down and record.
With the turn of the century and the advent of the First World War, incredible discoveries and advances were being made. The Norwegians created the polar map model, introducing frontal systems and air masses to the science. Aviation revealed some of the then unknown elements used in weather forecasting. Pilots could actually see weather as it moved across the map. With the 1940s came the weather balloon, a new way to take remote readings and observations beyond the surface. The so-called river of air we know as the jet stream was also discovered in the 40s. American B-29 bomber pilots on special reconnaissance flights during World War II encountered surprisingly strong and highly unexpected headwinds concentrated in narrow bands. These jet stream bands vary in size, speed, and number according to the season. The first TV weather forecast took place in the 50s and consisted of the bare basics.
Now isn't a cold front anymore, but is instead a stationary front. At least as far as central Wisconsin, then it turns kind of cold and goes on toward Canada.
A weatherman and a weather map, and some help from the friendly local Weather Service office. Weather forecasting really entered the computer age in the 1950s. Weather movements expressed in mathematical equations are assigned codes in a computer, and when weather data is fed in, a map model is produced. That's the easy part. The hard part is interpreting the information. Weather Service forecasters consider the computer one of the most important technological advances of the 20th century.
They're just so fast nowadays. You can cram a lot more of data into them, and they can give you feedback a whole lot faster than they ever used to be able to. And really everything, the 5, 6-day, 10-day forecasts, 30-day outlook, 90-day outlooks, that is all computer driven.
In the 1960s, satellites helped fine-tune the local forecast by actually tracking the weather. The first weather satellite was sent into orbit in 1960. Now present-day satellites furnish up-to-the-minute information from around the world. And now we have the next generation of radars, or NEXRAD. TV6's use of NEXRAD Doppler radar brings a new dimension to weather forecasting, actually looking into storms as they develop and giving forecasters and you advanced warning of threatening weather. How well do you know your weather history? Here are a few interesting questions to ponder. True or false? American B-29 bomber pilots discovered the jet stream. True or false? Practical weather forecasts were made possible with the invention of the telegraph. True or false? The first weather satellite was sent into orbit in 1975.
Thanks, Theresa. And by the way, she'll give you folks at home the answers to those questions a little bit later in the show. If you'll pardon the expression, the latest technology to take the weather world by storm is something called Doppler radar. Since you've probably heard a lot about that term lately, we thought it was time to show you what Doppler is all about. High atop this tower, overlooking the flat terrain of Scott County, sits what at first glance appears to be nothing more than a golf ball with an overactive thyroid. But in fact, beneath this geodesic dome lays the world's most powerful radar. The $5 million jewel in the crown of the National Weather Service. It works 24 hours a day, 365 days a year, scanning the skies in search of nature's most violent storms. This is NEXRAD, short for Next Generation Doppler Radar. Its mission is to provide early warning from severe weather events such as tornadoes, damaging winds, hail, and flash flooding. It was designed to meet the needs of 3 major government agencies: the National Weather Service, the Federal Aviation Administration, and the Department of Defense. What makes this radar so unique and special is its ability to measure motion and speed within individual storms. Since 1957, National Weather Service radars have only been able to show you where a storm is and how strong it is. With Doppler radar, we can go so much beyond that, it's almost mind-boggling. This high-tech radar can tell you in intimate detail what's happening within the storm. By measuring the speed of rain, snow, or ice droplets, we can obtain valuable data about wind patterns in our atmosphere. And that gives me an in-depth look into the structure of severe storms that never was available before. This is especially exciting when it comes to the detection and early prediction of tornadoes. We have learned that under certain atmospheric conditions, intense thunderstorms known as supercells will develop. These gigantic storms can climb to great heights, some more than 12 miles above the Earth's surface. Their beauty belies the fact that deadly forces are at work. That's where Doppler comes into play. You see, as the supercell matures into a tornado-producing storm, it will develop an independent wind circulation. Since the Doppler is capable of measuring these winds, it has the ability to pinpoint the tornado's formation in its infancy. It may still be another 20 minutes before the funnel actually reaches the ground. What this means to you is that warning time is increased significantly. Doppler has and will continue to save lives. Aside from its obvious severe weather benefits, NEXRAD Doppler has other advantages. Since it transmits with more power and a smaller beam width than other radar, it is much more sensitive. It displays data using 15 intensity levels instead of the previous 6. Its low threshold will display not only precipitation, but also clouds, weather fronts, pollution, dust, dirt, and even insects, all in greater detail. Just look at the comparison between the old technology and the new. We have come a long ways. So that's the Doppler, and hopefully you can see what all the fuss is about. But you know, it's one thing to spot the severe weather and another to get the word out. And that's where the first warning system clearly gives the forecast advantage to KWQC-TV6. If you've lived in the Midwest for any time at all, You know that we're in the middle of the severe weather season, and we all know that this is a dangerous time of year when storms can form quickly, and you need to be prepared. That's why fast, accurate, and understandable information is so important. Since time is such an issue, we're going to use it to demonstrate the difference between first warning and the old method of displaying weather watches and warnings. First, we'll show you how long it takes to get a warning on the old-fashioned way. Let's start the clock. A bell on the teletype alerts me that there is a tornado warning being issued. I rip it and check to see if any of our viewing area is affected. If one of our counties is under warning, I must determine for how long and what the specific details are. At that point, I grab an official warning form to fill out. There's a different one for each type of warning. I fill in the blanks with the necessary information, and I'm off to find the person whose responsibility it is to type in the facts and get it on the air. From there, it crawls across the bottom of your television screen. Next, I grab a coat and tie, alert the camera operators that I'm headed into the studio. When the director is ready and everyone is in place, we break into programming. The National Weather Service has issued a tornado warning for Scott County, and that will be in effect until 9 o'clock tonight. Bingo. Let's check the final time tally. Now, there's a time when we thought that was pretty good. Not anymore. Let's see how first warning compares. We'll start the clock again. The National Weather Service issues a tornado warning. The data is instantly transmitted into KWQC's first warning system. In the blink of an eye, first warning understands which of our counties is affected, determines the time the warning is valid for, prepares a color-coded map showing the specific county, and displays the information on your screen. You'll see it in two forms: a map in the corner of your screen which stays up until the warning expires, and a crawl across the bottom of the screen that gives you the necessary details. And of course, the time check was just 1 second. And the incredible thing about first warning is that it took just 1 second. All you need to know in 1 second. That's the difference between this and this. So when seconds count, you can count on us. We haven't forgotten the human touch either. Once first warning goes into action, you can count on either Theresa, Erik, or myself to be on the air shortly after the first warning map and crawl appears. Bottom line, when you see that map on your screen, it means you are tuned to the station, which will keep you posted when severe weather is in your area. Okay, it's quiz time again. Now I'm going to be a little tougher than Theresa and Erik and depart from the true-false question, so if you've got your paper and pens ready, here goes. What does NEXRAD stand for? Here's the next one then. What makes Doppler different from conventional radars? And here's the last question on Doppler. Why was NEXRAD Doppler created? These last two questions are about the first warning system. Ready? Why is first warning so important in times of severe weather? And finally, how long does the first warning map stay on your TV screen? Okay, we've looked at how man has learned to forecast the weather in the past, and you've seen how today's advances are already affecting our lives. But what's out there on technology's cutting edge? Where will science take us next? Stay with us and we'll show you what's on the horizon and give you a few more questions to ponder. And we'll have the answers to our weather quiz in part 2 of Eye on the Storm, a change in the weather. As you've seen, the business of forecasting the weather today is a far cry from the time when we first looked skyward and tried to guess what the next day's weather might be. But what's out there in our future, and what can we look for next? Here to answer those questions and to pose a few of his own is meteorologist Erik Maitland.
Well, Terry, it was predicted, it has arrived, and it's continually evolving. As a matter of fact, it'll probably be around in various stages of upgrade forevermore. And we're living in it. It's the computer age, of course, and that's exactly where the future of weather forecasting lies. Severe weather, not just a way of life in the Midwest, but all across the rest of the country and the world. In the United States, as in other countries, the concern surrounding severe weather is to issue the earliest warning possible so as to save as many lives and as much property as possible. In fact, in the United States, Congress has mandated a highly specialized government wing to forecast all kinds of weather. We, of course, know it as the National Weather Service. As satellite and radar technology have recently taken quantum leaps, and the best that any new developments in weather technology can do is monitor and attempt to predict, but certainly not prevent severe weather, what's next? And how can it affect the accuracy of the forecast we've all come to depend on to plan the weekend picnic or escape the fury of a tornado with our lives? The impact of the future of forecasting is going to be felt most in the places where a correct forecast is most crucial. Not to say that any error in forecasting is acceptable, but the daily task of alerting parts of the country to where severe weather is possible is a responsibility of these forecast meteorologists here at the National Severe Storms Forecast Center in Kansas City, Missouri. New developments that advance forecasting will be measured in terms of better accuracy and more advanced warning, making this an ideal place to introduce the future of weather forecasting. The future of weather forecasting lives in the further development of the 20th century's crystal ball, the computer. Although the potential of forecasting is not necessarily unlimited.
There's room for some more improvement, but probably not as much. There's not much more left to skim off the top, so to speak.
Especially when severe weather forecasts are about 80 to 90% accurate today, twice as accurate as 15 years ago. What forecasting potential is dependent on is mankind developing computers that will keep in step.
Well, data is key. More data, the better.
A meteorologist never seems to have enough information. He always wants to know a little bit more before he can come back and make a final forecast.
Where the need is, and maybe where we can make the most bang for our buck, is in improved models of the atmosphere.
The National Weather Service is currently going through a modernization process. The goal is to decentralize and streamline forecasting operations and also distribute more advanced computer systems to each office. Before, the National Weather Service was organized with each state having centralized forecast offices complemented by local offices. For the Quad Cities, the forecast is actually made in Chicago, with our local office handling the task of taking observations and issuing severe weather warnings. After modernization and a spreading of the wealth, if you will, in terms of talent and resources, Quad City forecasts will be made right here in the Quad Cities. Thanks to modernization, the new Weather Service office in Mount Joy is also part of the NextRad Doppler radar network that blankets the United States. And it will also be home to much more advanced computer workstations that will put all the information a forecaster will need right at his fingertips, making forecasting more of a science and less of an art form, and Weather Service offices like the one in the Quad Cities, local centers of expertise. All to meet the goal of issuing better forecasts and more timely warnings.
We will now be able to, instead of reacting to changes that have occurred in the atmosphere, we'll now be able to monitor it more closely and anticipate in advance of what's going to change. We do expect to see an improvement in the short-term forecasting here at the Quad City area.
But what about extended forecasts? These now encompass 3 to 5 days. It's hoped that soon 6 to 10-day forecasts of notable accuracy will be issued regularly. And to zero in on something of interest to the weather staff here at KWQC, what does the future hold for television weathercasting? Well, again, the potential is only limited by the advancement of computer technology. 3D fly-through graphics are already on the cutting edge, and with the further paving of the information superhighway, viewer interactive graphics could make an appearance in the fast lane. With two-way communication through cable TV lines and home satellite systems, you could pick and choose weather maps that you want. For instance, if you're planning a trip and the local TV weathercaster doesn't have time to offer more than a regional weather perspective, finding out the forecast for Los Angeles might just be a few digits away. So, as far as the future of weather forecasting is concerned, it's obvious, but only time will tell. But what about the future of television weathercasting? Well, stay tuned to KWQC-TV6 because as soon as it's ready, it will arrive right here. Now, here are some questions about weather's future based on what you just saw. True or false? Question number 1. The National Severe Storms Forecast Center in Kansas City, Missouri issues severe weather warnings, and local National Weather Service offices issue severe weather watches. Question number 2. Modern PC-based computer workstations will be the systems that will lead National Weather Service forecasters into the 21st century. And question number 3, with upgrades in the local forecast offices, operations at the National Severe Storms Forecast Center will be phased out. Well, we'll have the answer to these and the rest of our questions in just a moment. Terry?
Thanks, Eric. All right, the moment of truth has arrived. It's time to find out how you did on the weather quiz. And we'll start with Theresa Bryant and get the answers to her questions on weather history. Theresa, it's all yours.
And now it's time to see how well you did on our weather history quiz. Here are some answers. True or false? American B-29 bomber pilots discovered the jet stream. That's true. Pilots encountered this strong, narrow ribbon of wind during World War II reconnaissance flights. True or false? Practical weather forecasts were made possible with the invention of the telegraph. True. The advent of nationwide communications through the wire helped make longer-range forecasts possible. And our last question, true or false? The first weather satellite was sent into orbit in 1975. False. The first weather satellite was blasted into orbit a lot earlier, back in 1960. Since then, satellites have been an invaluable tool in understanding our climate and forecasting our weather. And now, let's see how well you did on Terry's part of our weather quiz.
Excellent, Theresa. So how do you think you did with the questions I asked about Doppler radar and the KWQC first warning system? Well, here we go. Remember, the first question was, what does NEXRAD stand for? The answer is, it is short for Next Generation Doppler Radar. The Doppler radar we use here at KWQC-TV6. Question 2, what makes this Doppler different from conventional radars? Well, Doppler radar is different than conventional radar due to its ability to measure motion and speed within individual storms. And our last Doppler question, why was NEXRAD created? It was created with the singular goal of providing early detection and warning from severe storms. Now, here's the answers to the last two questions on the KWQC first warning system. The first question asked was, why is first warning so important in times of severe weather? First warning is important because it can alert you, the viewer, in seconds instead of minutes that severe weather is on the way. And my last question, how long does the first warning map stay on your television screen? The answer is the first warning county map stays on your screen until the warning is canceled or has expired. Okay, we're into the home stretch now, and here once again with the answers to our final set of questions in our weather quiz is Erik Maitland. Erik?
All right, thanks, Terry. Now it's time to answer those questions about the future of weather forecasting. Question number 1, true or false? The National Severe Storms Forecast Center in Kansas City, Missouri issues severe weather warnings, and local National Weather Service offices issue severe weather watches. Now the answer here is false. The National Severe Storms Forecast Center in Kansas City issues watches, and local offices of the National Weather Service issue warnings. Remember, a watch is the time to prepare, and a warning is the time to act. Question number 2, modern PC-based computer workstations will be the systems that will lead the National Weather Service forecasters into the 21st century. Well, the answer here is true, you bet. PC-based computer systems that are being acquired by the National Weather Service right now are replacing outdated large mainframe computers that were acquired in the 1970s. The new systems, called AWIPS for Advanced Weather Information Processing Systems, show the forecaster all the information he'll need to know to make a forecast on just one screen. And question number 3, true or false? With upgrades in the local offices, operations at the National Severe Storms Forecast Center will be phased out. Well, the answer here is false. Although it will soon be moving to the site of the National Severe Storms Lab in Norman, Oklahoma, the National Severe Storms Forecast Center will still specialize in issuing watches nationwide, allowing the local offices to use new equipment to concentrate on issuing local weather warnings and more timely and accurate local forecasts. Hope you did well on those. Now back to my colleague, Terry Swails.
Thanks, Erik, and I hope you all got A's on your little weather quiz there, but more important, I hope you have a better understanding of how the business of trying to predict the weather, particularly severe weather, has progressed from folk knowledge and simple observation to computer-age science. And once again, KWQC will make available to our viewers an informational weather pamphlet, Surviving the Storm. Just send a self-addressed stamped envelope to KWQC, 805 Brady Street, Davenport, Iowa, and we'll get one right out to you. Or you can pick one up at Carl Cleve & Sons. For my colleagues, Theresa Bryant and Erik Maitland, I'm Terry Swails, and thanks for being with us.